Question 1. The straight metal arm of a windscreen wiper on a car rotates in a circular motion from a pivot point O through an angle of 140 degrees. The windscreen is cleared by a rubber blade of length 46 centimeters that is attached to the metal arm between points A and B. The total length of the metal arm OB is 56 centimeters. The part of the windscreen cleared by the rubber blade is shown unshaded in the following diagram. Cool. So first things first, I like to highlight or underline the important information in the question. So let's do that. So this angle of 140 degrees, that's going to be helpful. The rubber blade being of length 46 centimeters is going to be helpful. And the total length of the metal arm OB being 56 centimeters is also going to be useful. So we'll highlight all that, or in an exam, underline, or whatever suits you. And so this is so part of the windscreen cleared by the rubber blade is shown unshaded. So that's that little region there. Cool. Part A asks us to find the length of the arc made by B, the end of the rubber blade. Okay, so that's going to be this arc here. This big one there. All right. And the way we're going to calculate that is using the arc length formula, or length of an arc formula, which is in your formula booklet, which we'll write down here. So part A. And so it's L for the length is equal to theta over 360 times by 2 pi r. Okay. I will stress that theta has to be in degrees for this, and the r stands for the radius of the arc. Right, so, and we were told in the question, we know that theta is equal to 140, okay? And r is equal to 56 centimeters, because we're taking we're going from O to B. All right, so we need the full length of the metal arm, which is 56 centimeters. Okay, so now we're just going to bung these into our formula and put it into our calculator, and we'll have the answer. So we'll go L is equal to 140 over 360 times by 2 pi times by 56. Okay, now I'm pretty sure I've already got that in here. Yeah, we'll do it again now. 140 divided by 360 times by 2 lots of pi times by 56. Okay, gives us 136.8333 So what we'll do is we'll go 136.833. Okay, so these dot answers, just so you know, is it's completely unrounded. So this is just literally writing the answer or the number to the third decimal place, but not rounding to the third decimal to 3 decimal places. Okay, and then in normal IB fashion, we will round this to 3 significant figures, which will give us 137 centimeters. And we'll write the 3 significant figures down there. Okay, cool. That's part A done. That's the answer there. So let's charge on to part B. What have we got? So we've got to determine the area of the windscreen that is cleared by the rubber blade. So area of the windscreen cleared by the rubber blade. All right. So we're going to do a bit of thinking here. So we want to find this area here. The way we're going to do that is we're going to calculate this total area here. All right. All of this. And then what we're going to do is subtract. Oh, you can't really see that very well, but yeah, subtract this little area in here. Okay. And so in order to do that, we're also going to need to know what OA is, or the distance between OA. And if we see that O to B is 56 and A to B is 46, that means in here, this would have to be 10, right? Have to be 10 centimeters, right? So O to A is equal to 10 centimeters. And that means now we can calculate the area of the smaller sector, the small sector, and we can calculate the area of the big sector, and we'll go area of the big sector, subtract the small sector, and then that will give us the area of the windscreen. Okay, so let's go and do that. Oh yeah, we'll just leave our drawing on there. Right, so the area of a sector is also in your formula booklet, which I'll write here, which is A is equal to theta over 360 times by pi r squared. Same just as before, theta's got to be in degrees and r is the radius. Okay. Yeah, that's cool. So what we're going to do is we're going to say, so theta for our big sector and theta for our small sector, these are going to be the same. These equal 140 degrees, right? But our r for our big sector is 56 centimeters, and the radius, so I should have said radius for our big sector is 56 centimeters. And the radius for our small sector, which we calculated before, which was OA, is 10. All right, 10 centimeters. Okay, so we're going to need the big sector, subtract the little sector. So this is going to be A is equal to, so if we're going to put all the information for the big sector in, we've got theta is 140 divided by 360 times by pi multiplied by 56 squared. Okay, and now we're going to have to subtract the smaller sector. It's going to be exactly the same thing, but we're going to change our r from 56 to 10. All right, and then there we have it. All right, so let's go and do that. So I'm going to go 140. Actually, yeah, we're going to need some brackets here. 140 divided by 360 times by pi times by 56 squared. Okay, cool. Subtract now. 140 divided by 360 times by pi times by 10 squared, which I could have just put in 100, but let's do that. And so, yeah, there we have our answer. We got 3,709. In fact, we'll bring this down. I still got my red pen. Yeah, cool. So equals 3,709.173 ... All right, and so then in normal IB fashion, we'll round this to three significant figures, and so that's going to give us 3,710 centimeters squared. All right, and that is the answer.